is Megan McCarthy, and the deep dive I chose was fractions and fraction operations. Why I chose this topic. As a seventh grade teacher, I'm supposed to be expanding upon students' knowledge of fractions by teaching them how to operate with positive and negative fractions. But over the last 6 years, I found that many of my students still struggle with just the basics of fractions, whether it's finding a common denominator or just understanding what a fraction is essentially. After reading chapter 8 in our textbook, the reasons that I found that fractions are so difficult for students to understand is number one, because they can have so many different meanings. Number two, they're written in a unique way when you compare them to other numbers. And after learning how to operate with whole numbers, that knowledge is generally overapplied to related fraction concepts. So in general, a lot of students tend to struggle with fractions. And mainly, I think it's because they don't understand the basic knowledge of what a fraction is, what it's representing, before we start throwing, how do you add with a fraction, how do you subtract with a fraction. We need to really get down to the basics. And the last reason that I chose this topic was because I wanted to learn and find new strategies, models, and tools that I can use in my own classroom to help my students better understand fractions and fraction operations. They're an important part of not only math, but also life, when it comes to cooking. Also, my husband is a welding professor, and they use fractions all the time when they're cutting their metal, welding their metal, that kind of thing. And I want my students to be given the tools to be as successful as possible. So that's kind of why I chose fractions. On this slide here are the common fraction misconceptions. This is on page 117 of our textbook. These are just some of the basics that are found all around, not necessarily for every student or everybody. But on this page, you'll also find a table that gives you the misconception, gives you an example of kind of what it looks like, what we're seeing from students, and also how to help. So if you want more information on that, again, page 117 in the third edition of our textbook. The quote I chose to share by Vanderwall, Bay Williams, Lovin, and Karp, it comes from the 2018 third edition of Teaching Student-Centered Mathematics. Says the most effective way to help students reach higher levels of understanding is to use multiple representations, encourage multiple approaches, and elicit justifications and explanations. I think this quote is really fitting, not only for fraction concepts, but also for any math concept, math topic all around. Because these are three ways that I think that we can help our students better understand and reach a higher level of understanding of any math topic, especially fractions. The first teaching strategy that I wanted to talk about is the use of multiple representations. As you can see on the screen, I have 3 of them listed here. The reason I chose multiple representations and the reason I chose it as number 1 is because there's substantial evidence that has been found that suggests that the use of visuals in fraction tasks and, of course, other math topics helps students better understand, just giving them something to look at. I've also found that very true in my classroom alone. Students love to have pictures to look at or something to look at that represents the situation. The 3 models that we have here are area model, set model, and length model. The area model in the top right-hand corner is based on how a part of an area relates to the whole area. Some examples of that would be quesadillas being shared, a pan of brownies being cut up, or putting a playground on a piece of asphalt and how much of that area it takes. Right next to that on the right side, there is a visual of it. I really like this visual because I think we're so used to seeing circular area models, pizzas being cut up, excuse me, that kind of thing. So I really like that they showed how to do a fraction operation using the rectangular model. On the left-hand side, we have the set model. It's based on how many discrete items are in the whole set and how many items are in the part. Such as students in a class or items in a bag. Again, we see a lot of, boys versus whole class, boys versus girls, items in a bag, how many of one certain color of marble are in a bag. But just being able to draw out some type of visual there. And then the third one is the length model. Doing all of my research, I found that this one came up a lot. It is definitely one that we want to continue using in our classroom no matter how old the kids get, just because it's a great representation and can be used for multiple types of problems. Again, this one represents the distance on a paper strip or a number line, such as a distance traveled or string lengths. Again, number lines are very important in math. I think we just focus too much on the counting aspect of things, where it can also help us with fractions. I've also found that the use of multiple visuals to represent one problem helps students to build conceptual understanding, as well as helps them to decide for themselves which representation is best for a given situation. My second strategy is providing context. We need to give word problems because word problems help students make sense of the numbers before having to formally work with them in a mathematical sense. Giving the problem a context allows students to connect real life to the math to better understand the situation. Allowing students to invent strategies is always a great way, because then eventually, if they get the answer, then they can connect that strategy back to the standard algorithm, and now they have a personal way of connecting how to solve the problem rather than us just giving the algorithm. And then provide students with which manipulative or tool to use in order to solve the problem. For example, if the context is round, a pizza or a pie, then a circular area model is a good tool. But if the context is distance, then the students would recognize that a paper strip or number line would work best. So just giving them a context to work with. The third teaching strategy, instead of doing bullet points, I chose a quote from our book, page 25. Again, it's from Van de Waal, Bay Williams, Lovin, and Karp in the third edition of Teaching Student-Centered Mathematics. I think that this quote really explains the explain and justify strategy. This was found in chapter 2. The value of student talk throughout a mathematics lesson cannot be overemphasized. As students describe and evaluate solutions to tasks, share approaches, and make conjectures, learning will occur in that area are otherwise unlikely to take place. Questions such as those that ask students whether they would do it differently next time, which strategy made sense to them, and what caused problems for them are critical in developing mathematically proficient students. As they listen to other students' ideas, they come to see the varied approaches and how problems can be solved, and see mathematics as something they can do. By explaining how they did something or why a particular method works, students are developing their adaptive reasoning. So they can reflect on their strategies and decide for themselves what mistakes they may have made or possible shortcuts that they may have found through their discussions, which would lead to the standard algorithm. The teacher is also able to determine if students are using valid methods to find their solutions, and can determine which strategies should be shared publicly with the whole class. So allowing them to explain and justify gives the students an opportunity to share their thinking. How I want to apply what I learned. I want to apply what I learned by using more number sense in my classroom, not only for fractions, but for all topics in 7th grade math. If we can focus on the actual meanings of fractions and numbers instead of the procedures and algorithms for manipulating them, I think that more students will be more successful in math and be more willing to try new things without the pushback of not being a math person. I also hope to use the information I learned during my research, not just in teaching fractions. A few things that really stuck out to me that can be used throughout multiple topics are always provide a variety of models and contexts, make extensive use of number lines, and encourage estimation. Honestly, a few of these ideas seemed a little too elementary for me at first, but now I can see that no matter what age or level, all students will benefit. And the main idea that I hope to apply in my classroom and teaching is to allow students to explain and justify their answers and how they got there. There's something that came up in Chapter 8 of our textbook, but also in both of my research articles. Allowing students to explain their answers and reasoning, they are able to see possible mistakes made or even discover an easier path. They're also providing their classmates with other strategies that they may not have thought of before. And here are the 3 sources that I used in my research. Thank you.